Today we're going to be talking about angles in a triangle. Now the vertices of a triangle are the points where the sides meet. So we have one vertex is A, B, and C. Now the sides are CA, segment CA, segment AB, and segment CB. Now the angles, it's a triangle, so there's three angles. Angle C, angle A, and angle B. Okay, classifying triangles. And this I kind of expect you guys to already know. By the sides, scalene is when all sides are equal. I'm sorry, no congruent sides. So no sides are the same length. So then a isosceles. Be careful of this definition. At least two congruent sides. So at least means two or more, so two or three. Equilateral is going to be three congruent sides. Now by the angles, acute, all angles less than 90 degrees. Right. One right angle. Obtuse. One obtuse angle. And then lastly, equiangular. Equilateral meant equal sides. Equiangular, three congruent angles. Okay, there's a lot on this slide. Let's pull it piece by piece. So first piece. The angles in the triangle add up to 180 degrees. So that's a theorem. And we're going to call that our triangle sum theorem. Okay, now what a corollary is a statement that can be easily approved by applying this theorem. It's like a one or two step proof now that I know this theorem. So some corollaries. Two angles in a triangle are congruent to two angles of another, then the third angles are congruent. Meaning if you have two different angles in the triangles congruent to two different angles in another triangle, the thirds are also going to be congruent. We don't use that a ton, but this next one we use. Each angle in an equilateral triangle, an equiangular triangle measures 60 degrees. So each angle in an equiangular triangle is 60 degrees. Because all the angles are the same and they add up to 180, therefore they all have to be 60. In a triangle there can be at most one right or obtuse angle. Because if there was two right angles, you would have 180 degrees and you wouldn't be able to have a third angle. Obtuse, you'd have more than 180 degrees. And then the acute angles, we actually use this one a lot. The acute angles of a right triangle are complementary. Okay, classify triangle ABC by its angle measure. So the measure of angle A plus the measure of angle B plus the measure of angle C has to add up to 180 degrees. So now substitute in 6x plus 11 plus 3x plus 2 plus 5x minus 1 equals 180. So I have 9, 11, 12, 13, 14x plus 12 equals 180. So 14x is equal to 168. X is going to be equal to 12. Now I've solved for x. I have to plug x back in to get the angle measures. When I plug x back into the first one, I get 83. When I plug x in to the second one, I get 38. Plug it into the next one, I get 59. So classifying it by its angle measure, all of those are acute, so it is an acute triangle. Okay, so in a triangle, if you extend one side of the triangle, so I've extended this side of the triangle, this angle here is an exterior angle. The other two angles, not the angle that's a linear pair with it, the other two angles are remote interior angles. So those two angles are remote interior angles to that exterior angle. The triangle exterior angle theorem. This is an important theorem. This I always like to put on the final exams as an algebra problem. So prove this statement. So this is going to be the measure of an exterior angle of a triangle equals the sum of the measure of the two remote interior. So we have our picture, because we always have a given, a prove, and a picture. We have triangle A, B, C. I have angle 1, angle 2, angle 3, and angle 4. Now, two-column proof. It's going to look a lot like algebra, but we are given the measure of the exterior angle. I'm trying to prove the measure of the exterior angle. So the measure of angle 1 is equal to the sum of the measures of the two remote. So that equals 3 plus 4. What am I given? I'm given triangle ABC. So I'm given a triangle. So I'm given triangle ABC. Now, angle 1 plus angle 2 adds up to 180 degrees. And that is our angle addition postulate. Now, because 2, 3, and 4 all make up angles in the triangle, so angle 2 plus angle 3 plus angle 4, I now have three angles that add up to 180 because they make up the angles in a triangle. So that is our triangle sum theorem. Now those two quantities can be set equal because they both equal 180. So angle 1 plus angle 2 is equal to angle 2 plus angle 3 plus angle 4. And that is, by substitution, step 5. 2 is common in both. So I need to subtract that. So I state angle 2 is congruent to angle 2 by reflexive. Then I can subtract it from both sides. So then my step 6 is angle 1 is equal to angle 3 plus angle 4. And that is by subtraction. So this is a geometry concept I want you guys to know. Angle 1, the exterior angle, equals the sum of those remote interior angles. Okay, find the measure of each one of the angles. Well, I know, so I need to find measure of angle 1, measure of angle 2, measure of angle 3, the measure of angle 4. Okay, I know 58. This is an exterior angle. So 58, the exterior angle, equals the remote interior angle. So angle 1 plus 22. So angle 1 is going to be equal to 58 minus 22, which is 36. One triangle equals 180. So 180 is equal to 36 plus 22 plus angle 2. So I know now I can subtract angle 2 is equal to 122. Now angle 3, I wrote it in right away. Angle 3 is vertical with angle 2. So those angles are congruent. So angle 2 is 122, which also equals the measure of angle 3. Now angle 4, you have a couple different ways you could do it. You could say angle 4 plus 20 degrees is going to equal the exterior angle, which is 58. Or you could have done 22 plus 20 minus 180, or 180 minus that. So angle 4 ends up equaling 38 degrees. Next example, find the measure of the exterior angle shown. So I know this is an exterior angle. This is a remote interior angle, and 58 is the remote interior angle. So 10x plus 3, the exterior angle equals the sum of the remote interior angles. So now I simplify. If I subtract 7x from both sides, I get 3x. If I subtract 30 from both sides, I get 27. So x equals 9. Now be careful. X equals 9, but that's not the measure. I have to plug back in. I have 10 times x plus 3. So I need to now plug back in. 9 plus 3, well, that's 12. So that's 120 degrees. Okay, next I want to do a proof with you guys. And you can approach this proof a couple different ways. And whenever I do a proof, I'm just approaching it the way I see it. That doesn't mean that my way is the only way to do it. Okay. GK, step 1, GK bisects angle JGI. And at the same time, angle H is congruent, or the measure of it is equal to the measure of angle I. So that's given. Now mark up your diagram with what we were given. H equals I. I know that GK bisects JGI. So let's use that. I don't know how I could use H equal to I yet, but I know I can use that first piece of the given. So the first piece of the given, because an angle bisects, it breaks it up into two congruent angles. So angle 1 is congruent to angle 2. And that is by the definition of an angle bisector. Okay, now we've been talking about triangles and this exterior angle theorem. Angle JGI, that big angle, is equal to angle H plus angle I. And that is our triangle exterior angle theorem. Now, think about what you're trying to prove. You're trying to prove GK. I'll put it in purple. GK, I need to prove that line is parallel to HI. Think about the ways that we prove parallel. We prove parallel by alternate interior congruent. So if I could get 2 congruent to I, that would be helpful. Or corresponding. So 1 congruent to H, that would be helpful. So think about how you could do that. I know 1 is congruent to 2. I know JGI is H plus I. Well, JGI is also equal to angle 1 plus angle 2 by our angle addition postulate. So I know that angle H plus angle I is going to be equal to angle 1 plus angle 2. And that's by substitution because they both equal JGI. Now think about this. I gave you guys kind of a hint. We either wanted to get 2 equal to I because those are alternate interior, or we could get H and 1 equal. I know H and I are equal. So I know if I substitute in for I there, since H and I are equal, I can substitute in, and then 1 and 2 are equal, so I know I can substitute in for angle 1 there, angle 2, so that is substitution. The next step, well, I need to get 2 congruent to I. So I have twice angle I equal to twice angle 2. And that's really just addition or simplifying like terms. Now I can divide and I get angle I congruent to angle 2. And that is by division. Now that I have alternate interior congruent, we can now say that GK is parallel to HI because alternate interior congruent gives me parallel lines. Next example. Solve for values of x and y. Okay, so I know we have parallel lines. So I know this angle here is going to be equal to that angle there. So I know 2x plus y is equal to 5x minus y. So if I subtract the 2x over, I get 3x. If I add the y over, I get 2y. So y is equal to 3x over 2. Similarly, think about another equation we can set up. We don't have any exterior angles in our triangles, but we do have a big triangle there. We do have a triangle where 5x plus y plus 2x plus y plus 100 is equal to 180. Now combining like terms, I have 7x plus 2y is equal to 80. Now I have 7x plus 2. What did y equal? From above here, y was 3/2 x. So really I have 7x plus 3x equals 80. So 10x equals 80. X is going to be equal to 8. Okay, so x is equal to 8, so I need to solve for y. Y is equal to 3/2 of 8, so y is going to be equal to 12. There are your two lesson questions for the day, because it's kind of a long video. Please make sure those are submitted on time.